Welcome back to our deep dive, where we take your sources and really try to find the interesting bits inside.
Yeah, looking for those gems.
Exactly. And today, well, today's source points us somewhere maybe a bit surprising.
Mm-mm.
Using college-level math differentiation, integration up in agriculture, farming.
Oh, yeah, no, that's a fascinating one. The core idea here, from the source anyway, is using integration specifically
Okay.
to track the total volume of milk, lactation volume in dairy animals over a period of time.
Right. And the source connects this to what they're eating, like alfalfa grown on the farm.
Exactly. Linking the math, the measurement, directly back to the agricultural inputs, like alfalfa feed.
Okay. Alfalfa cows and calculus. It still feels like an unusual mix.
It does, doesn't it?
Let's try and unpack this link a bit. Abstract math and actual milk.
Well, what's really cool here is seeing how something you might just learn in a math class, integration, has such a direct, tangible application
Yeah.
on a farm, no less.
Right.
Think about it. Dairy farms, they can measure the rate milk is flowing right now.
Like liters per minute at this exact moment.
Yeah, precisely. That's a rate of change. That's related to differentiation, right? Measuring how fast something's changing.
Okay, yeah, I follow. Instantaneous rate.
But if you want the total amount, the total volume produced over, say, the whole milking session, or even, the entire lactation period for that cow, which could be months.
Ah, okay. You can't
Huh.
just use one single rate then. You need more.
You need to add it all up, sum up all those tiny little instantaneous amounts over that whole stretch of time.
And that's integration. It's the tool for, accumulating those rates.
That's exactly it. Integration lets you sum up that continuously changing rate over a duration to get the total accumulated value, which in this case is the total milk volume.
Mm.
And modern milking systems, they can actually do this. They have sensors, they monitor the flow rate constantly.
Continuous.
Yeah, or near continuously. And they use integration, well, the algorithms do, to calculate that precise total volume for each cow, each milking.
Wow. And the source ties this back to the feed, the alfalfa.
Right, because now you can measure the effect of things like diet changes, maybe different alfalfa ratios, on the total output, not just a spot check.
Okay, now I'm seeing the practical side. This isn't just like a neat math trick. It's actual farm management data.
Huge practical value. Knowing that precise total volume isn't just, interesting, it's crucial.
How so? What does it let a farmer do?
Well, think about it. You can predict yields much more accurately. You can properly compare different feeds. Does this alfalfa mix actually boost total volume?
Right, comparing apples to apples or alfalfa to alfalfa, I guess.
Exactly. And you can spot problems sooner. If a cow's total volume suddenly dips, even if the peak rate seems okay, that integration calculation shows the overall drop. Might be a health issue starting.
Ah, like an early warning system built from calculus.
Sort of, yeah. It just makes the whole operation much more data-driven, moving away from just occasional checks to, well, precise, continuous tracking and summing up. More efficient.
So, okay, let's wrap this thought up. What's the big takeaway here?
Well, I think our source material really shows how these powerful math concepts, like integration, that maybe seem abstract in class.
Yeah, they can feel pretty disconnected sometimes.
Right, but they have very real, very specific, and actually valuable uses, like measuring something as down-to-earth as milk volume on a dairy farm. It's economically important stuff.
It's a solid reminder, then, that the math you're studying, it's fundamentally a tool, isn't it?
Absolutely. A tool that pops up in fields you might never expect, solving practical problems, helping people make better decisions.
And maybe the thought to leave folks with, this example, the lactation, the integration, it's just one specific case, right?
For sure.
So, think about what else out there. Everyday processes, things in nature, maybe industrial stuff. What else could be measured or understood better if we applied these kinds of mathematical tools?
Yeah. What other processes are just waiting for that kind of precise quantification that math allows? It's a pretty interesting question.